tau is the most recent time of the most recent block. It's a time. That means it's a member of this set NT. Again, I think this is I think that should be sort of sans serif T. T prime is the posterior, and we just say, well, the posterior time should be set to the time of the mentioned in the header. Very simple. Okay. Now we have some more interesting stuff. E remainder M is tau divided by the epoch length. Epoch length, this capital sans serif E, that's 600. Right, I already mentioned that. The 600 time slots in an epoch. Each time slot 6 seconds. 600 of them means it's an hour. Simple. So we take our time, tau, we divide it by epoch length 600, and we end up, we do an integer division, and we end up with the E, which is the epoch index, the number of whole 600s in tau. And then we also end up with a remainder M, which is the fractional part. Yeah, the bit that will definitely not be 600, could be up to 599. And that's the number, that's the excess time slots, which gives us the phase, essentially, into the epoch, the number of time slots into the epoch that we're at, into the current epoch. So this essentially gives us an epochal address. Epoch index, and then time slot index within the current epoch. Yeah. We do the same for the posterior as well. And we can now do interesting stuff with this E, M, E prime, M prime. Right, so Safrol's basic state. Safrol has 4 bits to its state. Gamma K keys. It's the sort of keys that it's keeping in hand. It's the keys pending for the next epoch. Gamma Z, which is a ring root, and gamma Z and gamma K are linked. Yes, I think. We'll check that in a second. Gamma S and gamma A are the gamma A is the ticket accumulator, and gamma S are the tickets that have been selected as winners from the last epoch. The ticket accumulator is basically the 600 best tickets, characterized as having the lowest identity that we have seen thus far in this lottery. And we were in one lottery per epoch. So that's gamma A, the ticket accumulator. Gamma S is basically the ticket accumulator as of the last epoch, with a little reordering that we do for security. In case that the lottery doesn't complete correctly, then we may put in gamma S instead of tickets, just some Bandersnatch keys. Yeah, some public keys or validators. If we can't complete the lottery, then we don't know what the tickets should be, right? We just don't have 600 tickets. And so what do? Well, we disregard we were running a lottery at all, and we just pick some Bandersnatch keys. We just pick a random selection. This means that anyone looking at the chain knows which validator will be authoring in which slot. It's not ideal. It's a fallback, and we don't expect it to happen. Well, we don't ever expect it to happen, really, but if it does happen, it's like we just have to accept the fact that the network is running with less overall resilience in that case. And as I say, yes, gamma A is the ticket accumulator. Notice that it is, so Blackboard C is a ticket. It's the kind of the set of all tickets. These funny square brackets just mean we are defining a sequence of things, the sequence of tickets. And then it's subscripted colon E. E is the number of slots in the epoch, 600. Colon just means up to 600. So it's a sequence of up to 600 tickets. That's what this term means. And then here we have a sequence of exactly 600 tickets, or a sequence of exactly 600 Bandersnatch keys. Yeah. And here we are, our ticket definition, Blackboard C. Tickets actually have just two things in them. Y, which is a ticket identifier, 32-byte quantity, hash. And R, which is either 0 or 1. It's just, every validator, it just so happens gets 2 entries into the lottery. So we have to remember whether a ticket was their first entry or their second entry. That's all this R says. N in this case is 2. So N subscript, Blackboard N subscript 2 is either 0 or 1. It's a bit. Okay, now